Hi, this is Blake Smith from section MO4. In this lab, I analyzed the given video of the movement of a spring with the mass on the end. I used Tractor to track the motion of the object on the spring, and then I wrote a Python code to model this movement and to compare the theoretical motion to the actual motion. This lab deals with the momentum principle and the energy principle. The momentum principle states that the change in momentum is equal to the net force times the change in time. Relating to energy, in this lab we specifically use the definition of kinetic energy, potential energy, and the potential energy of a spring. Kinetic energy is equal to 1/2 times the mass times the velocity of the object squared. Potential energy of gravity is equal to the mass of the object, g, times g, the Earth's gravitational constant, times the height from the Earth. The potential energy of a spring is equal to 1/2 times the spring constant k, times the distance that the spring is from the relaxed length, squared. To start off, I tracked the motion of the spring and ball system in Tracker. Then it was time to code the simulation. We were given the mass of the ball, the spring constant k, the relaxed length of the spring and ball system. I used the Tracker data to determine the overall time to have my code running and to determine the original position of the ball, as it did not start at the origin. To start off, I defined the ball's mass, the original position, and the original velocity. I then continued finding variables by defining the gravitational constant, the relaxed length of the spring ball system, and the difference s between the length of the spring and the relaxed length. I then defined the potential energy of gravity, the potential energy of the spring, and the kinetic energy of the ball. Then I used the momentum principle I identified the forces and velocities needed to update the position of the spring. I then identified the different energy and the changes in energy. After that, I graphed those changes in energy to make sure the energy principle was satisfied. So what does it all mean? I graphed the kinetic energy, the potential energy from the Earth, the overall change in energy, and the potential energy of the spring. In this graph, the yellow line is the overall change. Because the overall change is 0, the energy principle is satisfied because the overall energy is conserved. Using the data from Tracker, from the X position data I found the average period of oscillation to be 1.646 seconds, and from the Y position data I found the average period of oscillation to be 1.519 seconds. The difference is due to the different forces acting in the X and Y directions. Thank you.